Hello friends, let us continue our discussion on carbon dioxide laser. In the previous video, I have discussed about the silent features of carbon dioxide laser and the different vibrational modes associated with carbon dioxide which are involved in the lasing action of carbon dioxide laser. Today, I will continue our discussion with construction and working of carbon dioxide laser. Now coming to construction of carbon dioxide laser, it is basically a discharge tube which is about 260 millimeter in length and 1 centimeter in diameter. So this is basically a discharge tube whose length is about 260 mm and the diameter of this tube is around 1 centimeter. One end of this tube has a partially silvered mirror and the other side has a blister's window followed by a completely silvered mirror. So this is one end and this is the other end, right? So one end of this tube has a partially silvered mirror. So this is a partially silvered mirror which is at one end of the tube. What is there at the other end? So the other side we are having a blister window which is followed by a completely silvered mirror. The difference between these two mirrors are that this one is partially silvered, that means part of the light which is falling on this, that will get transmitted through this mirror. But coming to this one, this is fully silvered, that means all the light which are falling on this, they will be reflected back from this mirror. So these two mirrors, this is first mirror, this is the second mirror. So these two mirrors, they are playing the role of optical resonator. Whenever light travels through this tube, this will pass through this blister's window and hit this completely silver mirror. And from here, whatever the light is coming here, they will be reflected back. They will pass through this blister's window and they will come back over here. And at this point, part of the light will be reflected back into the tube and part will be transmitted out of this mirror, which are the output of the laser. Okay. And the role of this blister window is to make the light polarized. Now, two electrodes are inserted into the tube to provide power supply. So these are two mirrors which are playing the role of optical resonator and this blister window that is polarizing the light. After that, there are two electrodes which are inserted into the tube. So here these are the two electrodes, this and this one. These are the two electrodes and these are connected to this tube, and through these two electrodes we can provide the power supply to the laser. So this is the power supply provided to the laser tube through these electrodes. Now you can see these are two openings over here. So what is the use of these two openings? A mixture of carbon dioxide, helium and neon is circulated within the discharge tube through these two openings. So from one opening the gas is going into the tube and it is coming out from the other side. So the gas or the mixture of the gas is being circulated through these two openings and the mixture contains carbon dioxide, helium and neon. Coming to the next component, it is a water jacket which behaves as a coolant, and this water jacket surrounds the discharge tube to remove the excess heat dissipated. So from where this heat is coming, when the gas electrons are moving, we will see later that scatterings occurs over here, and because of those scatterings heat is being generated inside this tube. And this water jacket which is provided over here, this is the water jacket which surrounds the discharge tube. The role of this water jacket is to cool down the discharge tube. Okay. So from one end the water is getting into the water jacket and it is flowing out from the other end. So while it is moving this way, that will take the excess heat which is produced because of the scattering of electrons and molecules. So these are the different parts of carbon dioxide laser. Now coming to the working of this carbon dioxide laser, so this is what we have seen, this is the construction, and in the previous video we have seen the different energy levels due to the vibrational modes of carbon dioxide, and these energy levels are responsible for the lasing action. As we discussed, this is the energy level which is associated with asymmetric stretching mode, and this is because of symmetric stretching mode, and these two are doubly degenerate energy levels which occurs due to bending of the molecule. Okay, so this is the energy level of carbon dioxide, right? Now I am attaching here the energy levels of nitrogen as well. So these are the ground levels. This purple color over here, these two energy levels are for nitrogen, and these red ones over here, these are for carbon dioxide. You can see these two energy levels are at the same energy. Further, these two are at the same energy. Now we will understand the working through this energy level diagram. So when an electric discharge occurs, the electrons collide with the gas molecules and the nitrogen molecules are excited to higher energy level. So when we will switch on, the power will be given to these two electrodes, and because of that the discharge will be produced, and because of that electric discharge the electrons, they will move through this discharge tube, and while moving in this discharge tube they will collide with the gas molecules, and because of those collisions the nitrogen molecules are excited to higher energy level. So these are the two energy levels of nitrogen. So initially the nitrogen molecules, they are in the ground state. When they are colliding with the highly energetic electrons, they will be transferred to the higher energy level, or they will be excited to the higher energy level. Thus, because of the collision, these nitrogen molecules, they are moving to the excited energy state. So what happens next? Now we will consider the carbon dioxide molecules at the ground state. So these yellow one over here, these are carbon dioxide molecules, and red one are nitrogen molecules. Further, I have marked these different energy levels for easy discussion. This nitrogen excited state and this asymmetric stretching mode level, both are almost at the same energy level, and I have given this as E5. The energy level which corresponds to symmetric stretching mode, that is denoted as E4, and for bending I have taken this as E3 and E2, and the ground state I am taking this as E1. Till now we have seen that because of the collision with the electrons, the nitrogen molecules, they are excited to the higher energy state, which is almost at the same level as E5 of carbon dioxide molecule. There is chance that these excited nitrogen molecules, they will collide with the carbon dioxide molecules which are sitting at this ground state. So when they will collide with the carbon dioxide molecules, they will transfer their energy to these carbon dioxide molecules, and they will come back to the ground state. So the excited nitrogen molecules transfer energy to the carbon dioxide molecules through collision and excite them to E5. They are colliding with the carbon dioxide molecules, and because of the collision they are transferring their energy to these carbon dioxide molecules, and as they are giving their energy to the carbon dioxide molecules, their energy will reduce, because of which they will come down to their ground state, and this carbon dioxide, they have received the energy from nitrogen molecules, right? So they will move to E5. Thus, because of these collisions, the excited nitrogen molecules, they will transfer their energy to the carbon dioxide molecules at ground state, and as a result the nitrogen molecules, they will come back to the ground state, and carbon dioxide molecules, they will move to the excited state E5. So this is the one way because of which the carbon dioxide molecules are moving to E5. Further, one more activity takes place. Those electrons which are produced due to electric discharge in the gas tube, those electrons, they will not only collide with the nitrogen molecules, there is probability that they will also collide with these carbon dioxide molecules, right? So when those electrons are colliding with these carbon dioxide molecules, some of these carbon dioxide molecules, they will get energy and they will move to E5. So some of the carbon dioxide molecules make transition from E1 to E5 through collision with electrons. So the carbon dioxide molecules which are at E1, they can move to E5 by two ways. The first way is when they will collide with the excited nitrogen, they will receive the energy from them and they will move to the higher energy state E5. And the second way is these carbon dioxide molecules, they will collide with the highly energetic electrons and they will take energy from that and they will move to E5. So as a result, we are getting carbon dioxide molecules at the energy state E5, right? Now if we will see and compare the energy levels E5, E4 and E3, we are having a number of carbon dioxide molecules at energy level E5, whereas there is almost no carbon dioxide molecules available at energy states E4 and E3. Thus, if we will compare the energy levels E5, E4 and E3, there is population inversion takes place with respect to energy level E4 and E3, because here we are having very higher number of carbon dioxide molecules as compared to E4 and E3. So this is the most important condition we need to have to get lasing action. So population inversion took place. So now what happens? These carbon dioxide molecules, there is chance that some spontaneous emission can take place and they can move to either E4 or E3. Okay, so when they are moving to E4, they will produce some photon. Further, when they will move to E3 also, they will produce some, or they will radiate some photons. But the thing is, as the energy gaps are different, the wavelength or the frequency of these two radiations will be different. So these are the photons which are radiated because of spontaneous emission, and we will call these photons as chance photons. So chance photons are produced due to spontaneous transition which leads to stimulated emission. Now these chance photons, when they will move inside the discharge tube, they will collide with the carbon dioxide molecules which are sitting at the excited state E5, and they will lead to stimulated emission. And the result of this stimulated emission is that the intensity of the photons will be very high and we will get high intense output. Thus, because of this stimulated emission, we are getting very high intense outputs, but we are getting two types of photons. One because of the transition from E5 to E4, and the second one is due to the transition from E5 to E3. Thus finally what we have seen, there are two types of radiations coming as output. One because of the transition between E5 and E4, and the second one is because of the transition between E5 and E3. If the transitions are different, we are getting different outputs. Let us see what are the outputs. So the first one is due to the transition from E5 to E4. Because of this transition, so whatever the output we are getting, the wavelength of that light is 10.6 micrometer. Okay, so the transition from E5 to E4 produce infrared radiations of wavelength 10.6 micrometer. There is another transition which occurs between E5 and E3, and because of this transition, whatever the output we are getting, the wavelength of that light is 9.6 micrometer, and this is also in the infrared region. Okay, so the transition from E5 to E3 produce infrared radiations of wavelength 9.6 micrometer. This is how we are getting two wavelengths in the output of carbon dioxide lasers. Now let us understand how the population inversion is maintained in case of carbon dioxide laser, because I have already told you that this is a laser where we are getting a continuous output. Continuous output means there is no break in population inversion, it is maintained throughout the operation. Okay. So now the carbon dioxide molecules, they have traveled from E5 to either to E4 or E3. So what will happen to these carbon dioxide molecules? Here the lifetimes are very less, so they will move to E2. The carbon dioxide molecules at E4 and E3 move to E2 through inelastic collisions. Once the carbon dioxide molecules make transitions from E4 and E3 to E2, here the carbon dioxide molecules are triggered by the helium atoms to make transition from E2 to E1. So whenever these carbon dioxide atoms, they are reaching over here, they will be triggered by the helium atoms and they will move down to the ground level, that is E1. So we are getting a huge number of carbon dioxide over here, and these are again pumped to E5 by collision with nitrogen molecules or with the electrons. Okay, so the total process will continue and the population inversion is maintained. So here the helium atoms, they will enhance the transition of carbon dioxide molecules from E2 to E1. As the population inversion is maintained throughout the process, the output whatever we are obtaining in case of carbon dioxide laser is continuous in nature. So we are getting a continuous output. The outputs whatever we are getting in case of carbon dioxide laser, those outputs are coming because of the transition of carbon dioxide molecules from E5 to either to E4 or to E3. So these E4 and E3, these two are known as lower lasing levels, and this E5 is the upper lasing level. Okay, so these two are lower lasing level. Let us now wind up our discussion on carbon dioxide laser by looking into some salient features of carbon dioxide laser. As discussed, it is a 4-level gaseous state continuous wave laser. 4-level means 4 energy levels are involved in the process of lasing. Gaseous state, because here we are using a mixture of gas like helium, carbon dioxide and nitrogen for the medium of laser. And further, the output whatever we are getting, that is continuous in nature, so it is a continuous wave laser. The carbon dioxide molecules are the active centers in case of carbon dioxide laser. Here pumping occurs through electrical discharge. The end faces of the discharge tube are silvered, which serve as optical resonator. We have seen that one side it is partially silvered and the other side is fully silvered, and the photons are getting multiple reflections between these two ends to make the intensity very high. So that's what these two silvered mirrors acts like optical resonator. Further, we have seen that the wavelengths of the emerging light are 9.6 micrometer and 10.6 micrometer. In case of carbon dioxide laser, we are getting high output power and the efficiency is also high. So these are some of the salient features of carbon dioxide laser. Today we'll stop here. If you like the content of the video, please press the like button and share the link with your friends. Also do subscribe to my channel, which will motivate me to create new videos. Thank you all.